Hello students and seekers of general truths. Now we look at a more complicated set of examples involving absolute value inequalities. Alright, so now we have the absolute value of this expression is less than 1. But remember that when the absolute value symbol is less than a number, the absolute value of an expression is less than a number, we're talking about in between. Right? This less than symbol here is really all the numbers in between two values. So we can set up this expression as 2x minus 7 is between positive 1 and negative 1. Okay? So just to recap, if we really think about in this previous example, the absolute value of x is less than 10, we're really talking about in between. Okay? The only difference with this question here is that the expression that we're working with is a little bit more complicated. Instead of just x, we have 2x minus 7. So now you see we really have a compound inequality. So add 7 to the left, add 7 to the middle, add 7 to the right, and we get 6 over here, 2x here, and then 8 here. Okay. Then divide everything by 2 and we get 3 is less than x, which is less than 4. So to graph this inequality, you have a number 4 here, and then you have a number 3 here, and it's a strict inequality, so we're going to go with the open circles. Okay, so this is my solution, my algebraic expression of the solution, and this right here is the graph. Moving on to the next example, you see now we have an absolute value expression and it's greater than. So it's going to be on the outside. So just to review, just to recap what we did last video, you see here we have, this is really x is less than negative 10, and this, or x is greater than positive 10. Okay, so it's going to be on the outside, and we're going to do the same thing here with this absolute value expression. 3x plus 4 is less than negative 10, and 3x plus 4 is greater than or 3x plus 4 is greater than positive 10. And then let's just solve each of these. So subtract 4 from both sides, and we get 3x is less than negative 14 here. 3x is greater than 6. Divide everything by 3, and we get x is greater than 2. And then we get x is less than negative 14 over 3. Okay, or. And this or statement comes along. Okay? So now we can graph our solutions. We have a 2 right here, and x is anything bigger than that. And then we have negative 14 thirds. Okay, so that's a little bit bigger than negative 4. That's a 0 right here. And x is anything less than that. So both of these arrows here are correct. It can be one or the other. Alright, let's move on now to something, let's just jump straight to the end here, where we have something that looks pretty complicated. I will leave you number 3 here to try on your own. And I will work through the more complicated example. So here we have an absolute value symbol multiplied by negative 3 minus something else. And what we want to do is isolate the absolute value expression. So the first thing I'm going to do is add 5 to both sides. If I add 5 to both sides, I get negative 3 times the absolute value of 2x plus 3 is less than or equal to negative 20 plus 5 is negative 15. Then we're going to divide by negative 3. So that gets rid of that negative 3 there, and you have 2x plus 3. Negative 15 divided by negative 3 is just 5. So let me review and show you my work here. Dividing by negative 3, dividing by negative 3. But remember one more thing, like I didn't write in this inequality symbol because whenever we're dividing or multiplying by a negative number, we have to flip the inequality symbol. Okay. So now that I've successfully isolated the absolute value, then I can apply what we learned from before. You see here the absolute value expression is greater than the number, so you're going to have an OR statement. It's going to have, just like here, the absolute value symbol expression is greater than a number, so we're going to look at the outside of the region. Okay, so we can separate this into two different equations. We can say that 2x plus 3 is less than or equal to negative 5, or 2x plus 3 is greater than or equal to positive 5, and then solve each of these by themselves. So add 3 to both sides, or subtract 3 from both sides, and we get that 2x is less than or equal to negative 8. 2x is greater than or equal to 2. Divide by 2, and we get that x is greater than or equal to 1. And then divide by 2 here, x is less than or equal to negative 4. And this OR statement needs to follow along. So now what we finally have is our answer. X can be less than or equal to negative 4. And we have a less than or equal to, so we could fill in this dot here and it goes this way. Or x is greater than or equal to positive 1. So we can fill in this dot and have it go that way. Okay? So this last example that we're doing here, it just illustrates that we can take what we learn and combine it with some other things. So we have something unfamiliar, a long complicated expression. So we do some work, we isolate the absolute value symbol, and we get to this problem, which is pretty familiar to what we've been doing. And then we solve it from there. So as always, keep working hard, ask for help whenever you need clarification. Thank you for watching, and have a wonderful day.